Constable, and I work for Microsoft, and I've been involved in Unicode for many years. I chair the Unicode Technical Committee, and my connection to text display is that for many years at Microsoft, that's what I worked on. I was hired at Microsoft to work on international text display. So I know a little bit about that, and I will let my co-presenter introduce himself.
Good morning. Is this on?
Yes.
Great. My name is Ned Holbrook. I work at Apple on text layout and fonts, and I also participate in several Unicode working groups as well. But I have an ongoing interest in this technology and am very excited to be here this morning. Thank you.
So why might you be interested in learning about text display? Well, maybe you're interested in actually working on text display software or working on fonts, and you want to start finding out a little more about what that's about. Maybe you're particularly interested in different writing systems, and you want to have an understanding of how they get implemented in software. And the text display is an important aspect of that. It's simpler for some writing systems. It's much more complex for others. Maybe you're possibly interested in proposing encoding of some writing systems in Unicode. Unicode doesn't yet have all of the world's writing systems encoded. And for some of them, how we encode it can be a little complicated, where the way that the text display has to be implemented becomes an important factor of how it gets encoded. Maybe you're working or planning to work in localization, and maybe you're not going to be specializing in text display, but if you're working in localization, you're often going to be testing scenarios where content in different languages is being presented in UI, and likelihood someday you're going to be encountering different text display problems, and so it would be good for you to have some understanding of how that whole part of the tech stack works. Perhaps you're working in NLP or are going to be working in other kinds of text analysis, where it will be helpful to understand how what you see written in text, how that compares to the actual encoded character sequences that your text processing will be analyzing. Because what is encoded in a file can appear very different from what you end up seeing on a screen. There's so various topics that we'll go through. Our focus is really going to be limited to, for a single line of text, how do you go from the Unicode characters to shapes at particular positions on the line? We'll talk about a few other things, but that's our primary focus. There's various things that we're not going to cover. So if you see something in this list that you're interested in, you can come and talk to us later. There's a couple of them that we'll touch on very briefly, but we're not going to go into any detail on these topics. So for instance, if you're interested in how do web fonts work, we're not going to talk about that at all. This is a tutorial session, so please do ask questions as we go along. We will be, for the recording, we'll be repeating your questions, so we're not going to be taking the time to hand around microphones. We've got a lot of content that we want to go through with you, so we're going to try to take questions and respond to them, but at some point we may say, hold that until we get to the end, or come talk to us later so we can get through stuff. Touch on a little bit of terminology that we'll use. So there's various terms that we work with when we're working in this field. Just a couple of things that I want to focus on. One is distinguishing between characters and glyphs. Characters are the things that are in a data file, and glyphs are the shapes that you see on a screen, right? So for instance, capital letter A is a character. The shape that looks like a capital A is what you see on a screen. That's a glyph. And if you read the Unicode standard, it talks about this distinction, and it will refer to glyph in an abstract sense, like all of the capital letter A's, right? We're going to use glyph in a more specific sense, which is really a particular shape from a particular font. A couple of terms with regard to font. There is a notion of font family, which is a set of fonts that share the same design traits. So for instance, Arial is a family of fonts. Then you have particular font styles. So for instance, Arial Bold or Arial Italic. When we talk about font, we mean the latter, right? It is a specific family and style. So those will be important to keep in mind as we go through the talk.
So with that starting point, let's talk basics. So the very, very basic sense of text layout as we understand it is just a sequence of glyphs all arranged on a line. We call that the baseline. But when we say a line of text, we mean that they're all just right next to each other, heading out into infinity. And so what we're going to do first is to just talk about the very, very simplest form of text layout, just so we have some basis for understanding some of the things that come later. So the example here, we have two strings that we have laid out and are displaying. So font data itself is organized into font files. They could be web fonts, whatever, but in this case, we're talking about an actual file on your computer. And essentially, it's a database containing groupings of information that are organized into what we call tables. So the different types of information in a font file include things like different strings, which describe the font file when you're looking at it in a file browser or a font manager. It has the actual data for the glyphs in the font, and it has, very importantly, some various metrics, which are different measurements relating to the font as a whole or to individual glyphs, and there are other types of data. But what's helpful to know about it is that all of this information is organized by kind into these various tables. And these tables are given mnemonic names. They're each 4 characters, and so we need to be a little bit creative sometimes, but being programmers who work with this data a lot, we have tended to try to name them in ways that help us understand what's going on. And so, for instance, the name table, that's what contains all the strings in the font. And the glyph table, very creatively abbreviated there, refers to a particular format of glyph data in the font. But what's important to know for the discussion going forward is that the glyph data itself is actually all of the glyph information arranged into a single table and referenced by glyph identifiers or a font index corresponding to a particular glyph. So they start at 0 and they go up from there, and however many there are is determined by that individual font. So when we're doing our font layout, we are assuming that we know what font we're dealing with. We've selected the font. The first thing we need to do is to map from code points to glyphs, and then we're going to figure out where they go in the line. So let's talk about those steps. The first step, which is kind of a jumping off point for everything that goes on, is to use a particular table called the CMap, which is an abbreviation for character mapping. And what that does is for each character that's supported by that individual font, it says what glyph is to be used to start this process of text layout. We refer to this as the nominal mapping or the default glyph mapping. But basically, it says in this example, we have a font. We're going to start with character A in this particular font and character B. And you'll note that the mapping from character to glyph is arbitrary in the grand sense, in that the font gets to decide what they are. So in this particular font, they're not contiguous, and that's okay. We'll get back to that.
What if I have a glyph that is
What if I have a glyph that's not a character? So that's a good question. We'll be discussing that in a future section. But you'll note, as I mentioned, since these glyphs are not contiguously mapped from the input, it's completely arbitrary. And so it could be that some of the glyphs in between there, glyphs 73 and 74, maybe there are other versions of A, maybe there's something else. Again, this is completely up to the font. And so we're going to need to interact with that font data to figure out how exactly to access those and when. So we've been talking about laying out these glyphs in a line. And so how do we do that? Let's say we've got a sequence of glyphs that we've already figured out where to put them. And what we're left with now is we have those glyphs and then we have our current drawing position. So really all we need to do is figure out what glyph comes next, where to put it relative to where we are, and how to get to the next step in the process. And so let's see how that goes. So in the font I mentioned, we have glyph data. You'll note in this example, it says up at the top there in small lettering, it says glyph index 72. So this is just how this particular font has been laid out in terms of its glyph data. And so we are going to then look at the glyph outline itself. And all of the glyph outlines are designed according to a set of coordinates on this design grid, the coordinate system for this particular font. But you'll note that for the outlines, the shape of this glyph, those outlines are controlled by a set of control points. And so those points have coordinates, X and Y coordinates on this grid. The font itself is going to provide us with some other information, some metrics or measurements. Some of these along the y-axis there are font-wide, but the ones that we're interested in on a glyph basis are the ones along the horizontal axis. So the most important information we're going to find is going to be, first of all, where the glyph is relative to the baseline, which is y equals 0, and the point at which x equals 0, we refer to the left side bearing. And so where those two x and y values correspond is going to be the origin for this particular glyph. The one other interesting piece of information that we're definitely going to need to know is what's called the advance width. And that's the distance from the left side bearing at x equals 0 to whatever x value it is on the right-hand side, the right side bearing. And that's referred to as the advance width. And so the distance between those 2 points along the baseline is the amount that we need to travel from the current drawing position to the next drawing position. That's referred to as the advance width because it's the distance we advance along the baseline. So let's put this data to use. So we know where we currently are. We've looked up using our CMap which glyph is going to correspond to the next letter in this word. We've found its origin. We're going to align that with our current drawing position. And then how we prepare for the next glyph is we use that advance width for this particular glyph to locate the next drawing position. And that's how we lay out glyphs along a line. Very, very simple. But let's keep going. So we've made a number of simplifying assumptions in this case. We have found in this particular example, very, very simple. For each character, we have a single glyph. The glyphs themselves are not dependent on one another. There's nothing fancy going on there. They're simply progressing along the line left to right. And all the information we need to know in this particular example just comes from simple lookups, right? The character mapping, the glyph data, it's all straightforward. And so with those steps that we've currently performed, we've developed some basic primitives. So obviously we know how to get from characters to glyph, but if you think about it, we also know in this example how to get from glyphs back to characters again, which is going to be helpful. We also know for this particular run of glyphs what their dimensions are. That is, like how much space along the baseline is required for the characters that we were laying out. And so now that we know that, we know how much text, not just glyphs, but by back mapping, we know how much text fits in a given width. And we can deal with user interface actions like a mouse click to find out where the insertion point is going to go. And we can also figure out, given glyphs, what characters correspond to if we're going to insert some more text in our original string. And we can also chain those operations together to figure out a range of text as I'm clicking and dragging to select some text, what characters actually correspond to that, even though the interactions I've been taking correspond to glyphs. So as I said, it's a very, very simple example. You might have some questions like, well, can glyphs overlap? Does there have to be any sort of arrangement to the glyph data and the origin? And do glyphs always have to have an advance width that progresses somewhere? And the answers are, as you'll find very commonly, no, it's not always going to be that simple. So I'm just going to advance this just one more step in complexity, just a tiny, tiny step. And that is this particular example of another glyph in the same font, some sort of accent grave. And you'll note that it doesn't have an advance width. You'll also note that the glyph outline is on the left side of the origin. And so it might not seem completely obvious, but this is a very helpful property to have, because knowing that the outline can take on a different position relative to our drawing position, if I were to take a letter and then draw this particular accent glyph as the next glyph, I've actually aligned the current drawing position after I've drawn my T with the origin of my accent, and you can see that in this case it very nicely overlaps the T, so I have an accented T, which is great. So what's wrong? Well, that is not going to take us very far, because you'll note that that particular glyph was designed just to match with certain other glyphs in that font, and so we're going to need to take some more steps to have things work out better. So already we've encountered a scenario where we need something more advanced than simply taking these glyphs and putting them out on the line one after another. So we should talk about what types of things we are trying to accomplish, like what motivations we have for making things more complex. So we've got several slides here with just some examples of types of things that occur, features of writing systems or scripts that we need to be able to accommodate. So the first would be some sort of more advanced positioning mechanisms. So in a cursively connected script like Arabic, we're going to need to figure out how glyphs interact, how to position glyphs relative to one another very accurately. We're also going to need to figure out how we can make the combining mark place more accurately with respect to not only letters, but even other combining marks. So on the left-hand side, we have some Arabic text, and you'll note that we have some marks above, and the position of that is obviously changing based on the heights of the letters that they're on. On the right-hand side, we have a word with a stack of accents, some above and some below a base. And we'll need to figure out how to position those marks not only so that they're appropriate for the base letter, but also so that they aren't colliding with one another. And so we're going to need some sort of positioning where we can determine anchor points on these different shapes and align them appropriately. We're also going to need to be able to adjust that advance width. And why would we need to do that? Well, a lot of times we're dealing with cases where the same shape needs different behavior according to the text. So the top is a example from Dyla script, and on the left-hand side, you can see we've got that accent. It looks like an accent acute, but it's a mark, a tilted mark on top. And in many cases, it simply appears over the base letter, as we've seen so far. But in some cases, you'll note that we need to essentially make some space so that nothing appears under it, and so that it can push the remaining glyphs out of the way so it has enough space. And so one way we can do that is by adjusting the starting advance width that the glyph defines and changing it later. Another common example has to do with interletter adjustments for typographic purposes to make the text look more pleasing. You'll note in this example the letters VAT and the TO in total. This is perfectly legible, but it looks like there's a fair amount of extra space in there, we might not really understand whether that space is intentional or whether it's just extra. And so by changing the advanced widths of those individual glyphs, we can squeeze things together so that things are more optically balanced, so that they're more pleasing. And this is a very common strategy called kerning, but kerning in general we can use when we talk about any sort of adjustment to the advanced widths of glyphs. We also have cases, going back to Arabic again, where we need to do something about the glyph shapes themselves. And so in that top line, we have this cursive example where highlighted in red, it's the same character every time, but it needs to take on a different shape based on where it appears in the word. And so rather than doing something to that glyph shape itself, we don't have that technology. But what we can do is we can figure out when to replace the glyph that we got from our initial CMAP application. We can replace that with a different glyph that has the shape that we need. And so that is a case where, again, it's just a one-to-one replacement. We're taking the original glyph that we had, and based on information about the text and the other glyphs in the line, we're going to substitute it with a different one. We may also need to take some sort of cluster context into consideration. So in particular cases, the same glyphs may need to appear differently based on what other characters are closely interacting with it. And so in this case, you'll note in the first line that initial glyph is taken together with another glyph and replaced with something, whereas in the second line, we're not doing that replacement, we're doing a different one, and that's based on the context of the cluster. So we'll talk about some cases of that happening as well. And then the glyphs themselves may decide, again, for other purposes that they need to take on a different shape and be substituted with a different glyph. Here we have cases where, based on what other glyph sequences are in context, they're influencing the choice of the blue replacement glyph. We may have cases in particular scripts where the user is expecting a certain sequence of characters to take on a particular form. And so this is a case where we can take a sequence of glyphs and replace them with one or more other glyphs. This is called a ligature substitution. A ligature is anytime you have many glyphs being substituted by one. And we may also even have cases where the choice of the language of the text that we're using may influence the glyph shape. In this case, we have a Cyrillic letter where maybe in Russian it takes one form, but Bulgarian or something, it takes on a different form. And based on information provided to the layout process, the font can offer that choice of glyph substitution. So again, we might even not be doing it for writing system purposes, but we might be doing it purely for aesthetic reasons. But one very common substitution that happens is with Latin typographic ligatures. In many cases, if you have a sequence of glyphs like FFI, the designer may choose to implement the font in a way that it would be best to replace that sequence of glyphs with a single composed glyph form with the shape that they prefer. And so again, that's that ligature substitution I was talking about, that many-to-one substitution, where our input sequence of glyphs, then the font will tell us how to replace that with a particular ligature. And one other example, this is a case where, again, the font designer has the choice as to how their design should behave. Oftentimes in an application, a word processor or something, you might have a choice of implementing small caps. So in text, this would be a capital Q and a lowercase UICK. And small caps is the process than where that word processor would capitalize the entire word, but then size those lowercase letters down when they're shown as glyphs to implement small caps. But the font designer may have supplied a better set of glyphs, which is more in line with the weight, the sizing, sometimes even the shapes of the letters. So there's a subtle difference here, but one side is something where it was made up, and the other is where the font designed proper glyphs for it. And so that's an example of an alternate substitution, that an optional substitution that we might choose to apply. And it goes on. We've been talking so far largely about writing systems which are purely left to right, but of course, this is not universal. Some writing systems require right to left text. Hebrew in this example is written right to left. And so in this case, we need to figure out how that is going to work. So again, the data in the font is it doesn't know anything about the direction of the writing, and so the text layout process needs then to perform the work using the Unicode bidirectional algorithm to reverse the order of the glyphs, because again, the origin of the glyph is unchanged, and so if we need the text to progress from right to left, we need to swap all the glyphs around in the other direction. And so we'll be touching on this a little bit more in future slides. Besides line reordering due to bidirectional algorithm, there are also cases where the glyphs in a particular cluster get reordered within that range. And so here we have an example of Devanagari text, where on the left-hand side, we have a sequence where the letter Ra turns into a mark above called the ref form. And when that appears in a cluster, it actually visually occurs at the end of the cluster, even though, as you can see from the broken out sequence of glyphs at the top there, in character order, it's relatively near the beginning. So we need to be able to move that to the end of the cluster. And likewise, the last glyph that we're looking at is actually a glyph for a vowel sign that appears closer to the beginning of the cluster when it's displayed. And so that also needs to be reordered within that cluster. So again, the overall line direction is left to right, but the glyph ordering needs to change. So advanced line layout, that is some of these processes we've been talking about, beyond simply the basic process of putting one glyph after another. We need that in many cases, not just for higher quality typography, but some writing systems, some scripts require that for part of their display. And so it's not something we can ignore and say, oh, well, we'll let someone else deal with that. No, text layout needs to deal with all of these situations at once. As a result of having done these processes, we'll note that we no longer have a guarantee of a one-to-one correspondence from characters to glyphs. We'll also note that the metrics that the font defines for each glyph in its nominal form, those default glyph metrics, they are not what are necessarily going to be used in the final results. So we're going to need to be able to make these adjustments independent of the font data based on the text that we're actually laying out in each circumstance. There is going to be more software that's needed to make these changes, but note that the logic of that software is highly influenced by data that the font provides. And so the trick here is finding out what data needs to influence those processes coming from the font.
So we'll drill now into what goes on in advanced text layout. And the first thing is that we are going to need some richer font data. So we need font formats that can support the glyph substitutions that need to happen, the positioning adjustments, and all of those things may need to be expressed in a context-free way or in a context-sensitive way. Yeah, and then we're also going to need some mechanisms for triggering these actions, these substitution or positioning adjustment actions, so that the right actions occur in the appropriate places. There are different font formats that are available. Of these three, OpenType is the most widely supported. So in all likelihood, if you're dealing with fonts with complex layout, it's most likely that you're dealing with OpenType fonts. So we're going to focus on OpenType as we explain things going forward. OpenType layout requires software that has some generic advanced layout logic, but it also is going to need certain script-specific logic, because there are different behaviors that happen in different scripts. For instance, we saw the cursive connection behavior in Arabic that needs to detect word position. But in other examples, like in Devanagari script text for Hindi, say, then there is different logic that's needed to deal with that case, because the behavior is very different. In the font, we're going to have different advanced layout tables, and there's three particular tables that are important for the layout. The GDEF table, glyph definition, that gives certain basic properties about the glyphs. For instance, distinguishing whether a glyph sits on a baseline or is a mark, and that's going to have some be used in the layout logic in particular ways. And then glyph substitution table, or GSUB. That has got all of the information in the font that is specific to those glyph IDs about the substitutions that would take place. Similarly, for positioning adjustments, a glyph positioning table, again with the font-specific details. Which glyph IDs have which positioning adjustments. All of those, we will sometimes refer to lookup tables. The lookup tables are contained in the GSUB or GPOS tables and express all of the substitution or positioning adjustment actions that I mentioned earlier. There needs to be a trigger, and for that we refer to font features. Think of a font feature as a typographic effect. Right? I want small caps, and so that's a font that's a font independent notion of the typographic effect. The actions then are triggered by that are very font specific. We've got different text layout implementations, and we're not going to go into any specific details about these. Key point is that if you're creating software that needs to support these capabilities, whatever operating system platform you might be targeting has this functionality built in. You don't need to go writing it yourself unless you are really, really bored. Okay, let's get into specifics of the layout process. We're going to go through a few different steps, and I'll talk about those in detail. So first, run segmentation. You've got a string of characters, and we need to divide it up based on a few important characteristics. The first being to separate it into script runs. And then we're also going to do bidirectional algorithm processing, which again will divide the text up. And then also another important distinction here are the style runs. I mentioned earlier that when we talk about font, we're talking about a specific family and style. And so if you change from Arial regular to Arial italic, those are two different style runs. And one thing that's important, because a lot of the operations, all of those actions are done in terms of specific glyph IDs. Glyph IDs are not shared between two different fonts. They're font specific. And so you can't have those actions occurring across a style run. So first of all, I mentioned script itemization. We want to use Unicode character properties to differentiate the character sequences that belong to one script rather than a different script. And again, that's because the different scripts can have different requirements about how layout needs to be done. So Unicode has a script property, and most characters have got a strong script property. such as Latin or Cyrillic or Devanagari. There are some characters like punctuation or symbols that may be script neutral, or combining marks are often treated as script neutral. And so there are these special properties of common or inherited. And in those cases, when we are segmenting the text into script runs, then we can merge the common or inherited characters into a strong script run. So next is the bidi processing. I'm not going to give you the full details of the Unicode bidi algorithm. We're just going to give a very simplified rundown of it. So in Unicode, every character is provided with a bidi class property. And many characters have got a strong bidi class, a strong directionality. So for instance, a Latin letter A is strongly left to right, whereas a Hebrew aleph is strongly right to left. But then there are also characters that have got weak or neutral directional properties, like punctuation typically is treated as directionally neutral. That's all important in how the bidi algorithm processing works. And I'm not going to get into all of the details about all of those things, but what we have to do, what the algorithm does, is for all of those weak or neutral characters, depending on the context in which they occur, it will reassign, in the process of layout, it will reassign to one of the directional property to one of those strong directional properties. So you end up at a point where all of your characters now have a strong direction in the processing. And then it starts to identify the level runs. And this is where the segmentation occurs. So you start with some base direction for a given line or paragraph. And let's say you're starting off with a left to right direction, and it proceeds forward. And then when it encounters a character that's got a different direction, then it creates an embedding. It creates a new embedding level, a new level run. We've just segmented the text. And so it's going to progress through the text and identify these different directional runs. At the end, you end up with runs that are in one direction, interleaved with runs in a different direction. And at some point, then, as a final step, essentially everything that had a right to left direction, all of the characters get reversed. So when we do the layout, like when we're actually positioning glyphs, we're actually positioning everything in left to right order, even though some of the characters were strongly right to left order.
You just define a segment again.
A segment.
Yeah, when you talk about segmentation, run
Oh,
segmentation.
okay, sorry. So question is, what do we mean by segmentation? That just means dividing things into different parts. So I could start with a string ABC 1, 2, 3, and I might segment into the letters versus the digits. So we end up with two segments. But we're going to be segmenting the text based on the script of the characters. We'll also be segmenting the text based on the bidi level, directional levels. So with the bidi, here we get this example. The top shows the ordering of the characters as they are encoded in a document. And so you begin with some Latin characters, and then you go to this Hebrew run of Hebrew characters, beginning with Aleph, Mem. After you do the bidi processing, you start with that Latin left to right run. Then you have this Hebrew run. And notice now the Aleph and Mem are now on the other side. It all got reversed. So this is showing you how these work together. Up there at the top, you see a text to analyze. It's got hello in English. It's got some Arabic text. In the middle of the Arabic text, there is a number, a digit, which is going to be significant. And then there's some Chinese characters at the end. So we do a segmentation into script runs. So it begins with the Latin run, then it switches to an Arabic run, and then you end up with a pan-Indiograph run. You also segment according to the bidi levels. So we begin with this English run, and then we start into Arabic, but I mentioned that digit. The digits, even Arabic digits, are actually not the right characters. And so that's why that run of Arabic script text, when we do the bidi analysis, gets broken up to different parts. And then the Chinese characters at the end. When you combine those then, we had 3 different script runs and we have 5 different bidi runs, but you merge those to get this combination of script and bidi level. So you have 6 different runs. So in subsequent processing, we're then going to be operating on individual runs. Now, I didn't mention style runs. This is assuming this is all in the same font style. But of course, if you also had text in different font styles, that would be an additional segmentation that goes on. So we've segmented the text, and now for each of those runs, the next step is what we refer to as shaping. Shaping is going to take us from an initial character sequence to the final set of glyphs that we have to place. So starting with character sequence, ending up with a final glyph sequence. There's other inputs that will and outputs that we'll be considering. The process is going to include doing any glyph substitutions, dealing with all of the reordering, whether that's the bidi reordering, or so an example earlier, a case where within a single cluster, there were pieces that needed to get moved around. So for the shaping, we're going to go through different steps, and I'll talk about each of these. So first of all, canonical decomposition. There are characters in Unicode that, for whatever reasons, encoded as a single character, but they've got multiple pieces. So these are some Malayalam characters. The first is a consonant, and then a vowel. And the vowel has got 2 different parts. And the dotted circle that you see in the middle is suggesting where a face for these marks needs to go. So one of the characteristics of scripts of South Asia is that you get some letter that is sort of like a base for a cluster, and then you have other pieces that can orbit around it, sometimes referred to as like a satellite. You can have pieces above, below, to the left, or to the right. So this is a case where this one character has a piece that needs to appear at the base, another piece that needs to appear on the right of the base. In Unicode, there is a decomposition mapping of the character. And so that is equivalent to the sequence of 2 characters. When we are laying out this particular sequence of character, we need to decompose those things. There's also character level reordering that we can be doing. So this is one of those cases where I talked about within a cluster pieces that need to move around. It's not the only, but it is one of those cases. So that at some point, that mark and the base consonant that it goes with, those things need to get switched around. We also need to do analysis of a cluster. And in many scripts, this is going to be a trivial operation. Like for a Latin script, it's not that important, but for some scripts, it's absolutely essential. And again, for scripts of South Asia, this is an absolutely essential part of the process. We need to look over the sequence and identify different structural elements within that sequence. So this is these are sequences from Devanagari script on the top and Oriya script on the bottom. And they are very similar in, they are both consonant clusters, ending with a vowel mark. But we'll see that there are similarities in our cluster analysis, but also some differences. And that's because the scripts have different shaping behaviors. So we start at the left. And in both cases, the first character is ara. And when a ra begins at the beginning of a consonant cluster, It's typical that it forms this mark that Ned referred to earlier called ref. Next, in the definite case, we're going to have a consonant that is going to take on what's referred to as a left joining conjunct form or a half form. So it's going to stay on the left, but take a different shape. Then we have what is the base consonant, the thing that is sort of the heart of this cluster. Then after that, we have consonants that will then take an alternate shape and go below the base. And in the case of Oria, now we have one more consonant that takes on an alternate shape, but it doesn't go below, it's going on right. And finally, in both cases, there is a vowel mark. It's important for us to do this analysis because we need to know for different portions of the cluster which typographic operations we need to request. I talked about features earlier. We're needing to determine which features we need to apply to which portions of the text. So once we've done that analysis, then we can go on to the next step, which is to actually perform the substitutions. And this will be using, in OpenType, we use the G-sub table, the glyph substitution table. And there's different kinds of actions that can be done. There can be a one-to-one substitution, replace one glyph with one glyph. You can have replacing one glyph to a sequence of many glyphs, or the alternate, replacing a sequence of many glyphs to one glyph, what we referred to earlier as a ligature substitution. And so we've got those different action types, and then the features, as I mentioned earlier, are the trigger. Right? Do this typographic operation. Again, the feature is font neutral concept. The actions are not specific. So, well, I'll walk through a particular example. This is again from Demystifying, and we start with that initial character of ara. And so we need to request a ref form. We're going to take those two glyphs and we're going to do a substitution to that ref form. Then next, the next three glyphs need to combine in a particular way. It's going to be a ligature substitution to one glyph. And we refer to this as a rakar form. And then when we're done, that rakar form that we just created, it needs to change yet again to a half form. And then finally, we get the final sequence of glyphs to provide the right shape for our cluster. Now, the range within the cluster over which we apply each feature is critically important. So here you notice that in this sequence, we've got two occurrences of the ra, followed with that halant mark or virama. So if we were to apply the ref form feature over the entire cluster, then we would end up creating two ref glyphs. But there's only one base, and a base can only have one ref on it. So this isn't good. But this is what would happen if we were not using that cluster analysis to determine which portion of the cluster actually needs the ref form. And so, again, you can just step through that. We needed to identify the particular portions to apply each feature to get the right shape. Once we've done that shaping, we started with characters. And after we've done the cluster analysis, we figured out which features to apply and which portions. We did a bunch of substitutions. Now we've got our final glyph sequence. Now we set the glyph positions. And we started with their nominal forms. You can make adjustments. So here we're using the glyph positioning table or GPOS. This is going to be simpler than the shaping because we don't need to do any cluster analysis. We will have a set of features and they just apply to the entire run. The actions, we can make adjustments to the placement of the glyph in relation to the origin. In a sense, you could say we're shifting the origin. And you can do that by absolute values. You can, Ned referred earlier to attachment points, right? So I can say, this is a point and on one glyph, and this is a point on another glyph, and that's how those glyphs need to attach. With cursive connections, you can, like in Arabic, you can do a similar thing. This part of the skeletal shape has an attachment point that it needs to line up with a corresponding point in the next part of the skeletal. You can also make adjustments to the advanced widths. And all of this can be done either on single glyphs or on pairs of glyphs. A simple example here, let's say we start with this glyph sequence. We've got one base glyph and two combining marks. And so first of all, we're going to do a mark to base attachment, and those little red crosshair is sort of suggesting the anchor points, and we're aligning those two anchor points. And just as you do it mark to base, similarly you do it from a mark to another mark. You align those anchor points, adjust the positioning that way. So those are our basic operations. Well, not basic, those are advanced operations. And earlier when we talked about the basic layout, we said, all right, once we got to that point, there were a bunch of other related things that could be done that would, for instance, allow us to measure text, allow us to go from a mouse click position to somewhere in the text. All of those same kinds of things apply here. But what's important to note is that to do all of these things, you have to have done the entire advanced layout process, from segmentation through shaping through glyph positioning. Otherwise, you don't know what's the dimensions of the text. You don't know where glyphs are actually positioned so that you can work back.
So all of those steps that Peter were talking about, we've been assuming that the font that we've selected and are dealing with supports all of the characters that we need to render. And so here's where we need to talk quickly about font fallback. What happens when the font that we have selected doesn't actually have the ability to render all of the text that we need? So font fallback then is the process of figuring out some font that can show the text that we need to display. So in this example, I have a font selected and I have a string that I'm trying to display, but it turns out the font that I've selected doesn't actually support all the characters in that string. And so if I simply tried to use that one font for this entire string, all that font could do is say, hey, I don't have a mapping for all of the characters that you need. And so I'm just going to give you what I call the not def box. That's glyph ID 0 in a font. And font designers can go as creative as they want to get, but hopefully we'll never see it because this is not helpful. What am I trying to show? And so we talk about font fallback, even though it's not strictly part of text layout, but it is part of our requirement to make sure that people can read the text that we're trying to display. And so we are going to need that at some stage to make that happen. So if then I perform some font fallback on this string, you can say, oh, that's what I was trying to say. And so once we've done that font fallback, we can actually read the entire string. Now, I've highlighted the portion that the fallback actually applied to there in green. Of course, it's not always entirely simple because font fallback is not something that is well defined. That is, it's not always going to behave the same in every application that you're dealing with. And so depending on the requirements of the software, it may make different choices. So the very first question that the software needs to ask is, hey, what do I need to change? What text actually needs fallback? And so if you click ahead just one step there, you might ask, well, isn't it obvious? We just need to replace the stuff that we can't see. But in many cases, we are dealing with clusters or cases where we have a letter and some other marks or some other letters even that are dependent on one another in order for proper display. And so maybe even the font that we would like to use supports some of the characters in a cluster, but not all of them. And so the software is going to need to look at various character properties and decide, well, do I need to use a different font for just this one character or more, an entire cluster or even more context? And when I say context, what do I mean? Well, in some cases, hopefully, I'm going to have a choice of multiple fonts that I can use for fallback. Hopefully, it's not something where I only have one choice and that's what I'm going to use. But people, when they're dealing with fonts, they often have various expectations of those fonts. One of those might be what language they expect that font to be designed for. One example is for ideographic scripts like Chinese and Japanese. Well, those share the same characters in many cases, but the readers of those languages have different expectations. They know what a Japanese font looks like, and they know what a Chinese font looks like, and if you give them the wrong one, they're likely to complain, and rightly so. And so one of the things that font fallback might need to do is to figure out, given multiple choices on a computer, which font is going to be the best for the user's preferences. So the types of things that the software might be able to consult would be whether the user has said that they prefer a certain language. You know, if this user says, oh, I speak English and also Chinese, then you would know, oh, well, the software should give them a Chinese fallback font if one is available. There might be other preferences as well. For instance, different Arabic written languages use different font styles. The user might have set those preferences as well. If that's not available, well, maybe the software can figure out which keyboard you're using. That's a pretty obvious indication of what sort of font might be appropriate in that case. Or you might just get lucky, the software might get lucky, and it might actually have some additional information that informs the font selection choice. Like in a web page, for instance, you might have some sort of language tagging. It says, oh, this paragraph or this span is this language, and that really helps the font fallback selection. Once we have some of that context, we decide what range to apply the fallback to and what the user preferences might be. Again, hopefully we're in a case where we have multiple fonts to choose from. In that case, we might be able to pick something that looks nice. And by default, that's going to be something that matches the general style of the original font. So one of the things that we can do is determine the classification, or what CSS calls the family of the font. These are different typographic design traits like serif, sans serif, cursive. And in many cases, those classifications can be determined from information in the font itself. CSS defines some other families, though, that currently aren't specified in fonts individually. And so the software might have to have some other information to help it make appropriate font choices. So a web browser might say, oh, I know a good Fengsong font that I can use for this Chinese text. Additionally, within that font family, remember, those are the related styles of a single typeface. We might want to pick one that matches some of similar attributes in the original font. So let's say I am trying to lay out some text using an expanded italic font. Well, if I have some choices, I might be able to select something that matches along those attributes as well. And finally, okay, but what fonts can I actually choose from? And sometimes these can differ even on the same platform. The fonts that you use when you're typing in a messaging app might be a different set of fonts or no font options available to you from when you're dealing with a word processing document, where you have a whole listing, a menu full of fonts. And so that can constrain the amount of choices that we have when selecting a fallback font. And another interesting thing to note is that in some cases, like in a web browser, it might be possible for the web page or the web server to find out what font was used on a given page. And for some people, that can be a privacy concern, because maybe you're dealing with a minority language and that you are identifying yourself as a part of a smaller group. Or maybe you simply don't think that the web server needs to know what's happening on your computer, in which case web browsers might choose to limit the set of fallback fonts to something which is more universal and therefore less indicative of who you are or what text you're reading. So related to fallback, I bring up emoji because, well, interestingly enough, emoji are one of the most common occurrences for many people in the West of advanced typographic layout. You might say, what do you mean by emoji advanced typographic layout? Well, emoji themselves are actually quite complicated when it comes to their actual text encoding, how they're represented by characters. And so software needs to perform advanced text layout to figure out which emoji to show to the user. And so largely this is driven just transparently by font fallback by computer software. And so software is going to use various information about the text to select an emoji font to display a sequence of characters that the user wants to see as emoji. And I would note also that since this process is informed by the actual font itself, there's no requirement that the emoji font shows a color glyph for a given emoji. You might be dealing with a terminal emulator or something where the font fallback stack chooses to present a black and white font instead. And again, the exact appearance of those emoji is going to be driven by the glyph data in the font. So I'm just going to toss this up here. You can come back and look at it later in the replay if you want. But for those of you who are curious, there are 3 major font formats for dealing with color glyphs. They each have some advantages and disadvantages. What's interesting to note is that one format provides bitmap data, like a ping, if you're familiar with that graphic format, but still behaving like a font in terms of being able to resize it. And then there are 2 outline-based formats that offer different degrees of complexity and graphic operations. But when I mentioned that we need that advanced text layout, we're still going to take some text in and get some glyphs out. But oftentimes when we're dealing with emoji, we see a lot of these typographic ligature substitutions. That's the case where we're taking many of those nominal glyphs and the font is providing the data to replace it with a single glyph that's to be used to display it. So here we have a sequence. In text, it's actually 4 characters, but of course, we expect to see that as a single glyph. And so that information, once the font fallback has selected the appropriate emoji font, is going to be available in the font for the advanced text layout to make those substitutions and get the final positioned glyphs. And so again, this process is no different from any other text layout. What we have here is a case where the font may end up saying, oh, like this is the glyph you need and this is where it goes. And so from the layout perspective, there's nothing really special that's going on with emoji. It's the actual rendering software that says, oh, I have this glyph index that I need to display. And aha, this particular glyph index has some sort of color information that I need to display. And so the layout doesn't necessarily know that that's what's going on, but the rendering software on the computer is going to know what to do with it. Now, one thing, other fun fact dealing with emoji is that we mentioned before that as a result of advanced text layout, there can be a divergence in what the glyphs are and what we expected from the characters on the input. And the same is true of emoji as well. A particular font, for whatever reason, may choose to actually vary the number of glyphs that we need to display a given emoji. And so we can't even assume that one sequence of characters for an emoji cluster is going to display as a single glyph. Here we have a case where we have a couple and the font represents different halves of the single emoji using different glyphs. And so on the left, you can see that the font has produced 2 glyphs and uses a positioning adjustment to overlay one on top of the other. So one of them obviously has a 0 advance width and the origins are aligned. And then the second one has a positive advance width, or maybe it's the other way around. We don't really know. But this is an interesting example where we make assumptions about what text layout is going to produce. But again, that's up to the font designer to figure out how to produce that layout. And finally, you might say, okay, well, this is great, but rarely do I have a screen that says, why does the entire document I need to produce? So at some point, we're going to figure out how to take that single conceptual line that we've produced from text layout and show it on multiple lines. Like if we have a single paragraph and we're trying to fit it on a page, we need to figure out what to do about that. So we're not going to go in the details here, but remember, throughout this process, we've been developing these primitives, and one of them is figuring out how wide a given sequence of text is. And so if we can use that ability along with some of the properties and information that we know from the Unicode characters themselves, we can figure out, given the width of our page, how much text, that is how many glyphs when laid out in a font, can fit in that width, and find an appropriate place to perform a line break and start displaying the next line of text below it. So this is a bit of an involved process, especially when we deal with the bidirectional algorithm, for instance, because those parts we may have moved around. But again, we have the information we need. We can perform this. And the font itself provides some metrics. In this case, we have the ascent and the descent. These are distances above and below the baseline. And we can use that as a starting point to place these lines on top of each other. But again, this is just a starting point, and we may be dealing with a word processor and need additional line spacing for our term paper or something like that. I don't know. So we just use this as a starting point for performing multi-line layout. So we've done a lot of good. Now comes the bad. So there are a number of things that can go a bit wrong depending on how things turn out. Remember, we spent a fair amount of time looking at some examples of this cluster analysis that we can perform. But unfortunately, the text that we're dealing with might not always be strictly correct. And in some cases, we can end up with an invalid cluster. And these are cases where there's something about the characters or their sequencing that doesn't produce a valid result. And usually what happens in this case is the shaping engine, the script-specific logic, will try to indicate somehow that something is wrong. And so there are different reasons why this can happen. One, which is shown in the example here, is one where Unicode provides a list of certain character sequences that should be avoided for whatever reason. Again, maybe this is due to some encoding specific concerns, or maybe it's a case where if you have 2 different sequences, and didn't indicate the problem, they might look the same, and therefore you'd end up with text that you couldn't search for the word you were looking for because it was encoded improperly. There may be other reasons as well. For instance, that cluster analysis requires on the various components of that cluster being in a certain order relative to one another. And so if the cluster is malformed in some way, those components are out of the expected sequence, we might see an indication like this dotted circle as well. And so in these cases, even though the dotted circle is being produced by text layout, it's not a bug in text layout, is an indication that something wrong with the text itself. And so in many of these cases, it might be something that you might not be expecting, and you might need to take a moment and consult an expert to find out what might be causing this. Another problem is that we deal with PDFs a lot, and people often think that PDFs contain text. And they kind of do, but they also mostly don't. PDFs are largely just us reconstructing a glyph layout. And so when you're looking at a PDF, none of this advanced text layout is actually happening. The PDF itself says, glyph goes here, glyph goes here, glyph goes here. And so from those glyphs, it might be possible, again, in that basic text layout example, we saw there was a one-to-one mapping. And so in those cases, speakers of these, Latin-based writing systems, we might have it easy. We might say, oh, that's the word fire because, oh, we figured out that that glyph comes from this character. But in many other writing systems, that's not always possible. Now, the PDF format tries to accommodate this and may allow some extra information that helps reconstruct the text. But unfortunately, we can't always rely on it. And so one of the cases where the text display may be okay, but the actual text itself can't be recovered, maybe when dealing with the PDF document. That is unfortunately an outcome of how it was designed. And so you might need to be aware of that, whether it's identifying a better way of producing the PDF so that you can maintain that extra information to get the text out later, or I don't know, maybe not use PDF. Anyway, that's fine. Oh yes, absolutely.
So if you, so when you actually copy
Yeah.
text or glyphs from a PDF,
Yes.
and you paste it into, say, a Word document, what information does that copy action carry over to?
Right. So the question is, when you select text or glyphs in a PDF document and you paste them somewhere else, where is that information coming from, basically? So like I said, in some cases, it's obvious. The software can see, oh, this is the one character that can produce that glyph. Easy peasy, no big deal. But in other cases, again, those glyphs could have come from a situation that can't be deduced after the fact, right? And so that's a case where some readers may be able to deduce some of that information based on whatever is in the PDF font or the document itself. But ultimately, for complete fidelity, the only way is to make sure that when the PDF was produced, it contained the extra information that allowed the reader to extract the text after the fact. And so that, again, is a case of maybe we need to find a better way of producing that PDF, because otherwise the information might not be retrievable at all.
One other aspect of PDF, as Ned said, it's basically a reflection of glyph layout, not the original text, right? And if you've got any complexity in a document layout, like for instance, you may have running paragraphs of text and then little callouts on the side. And the way that that gets structured inside the PDF file may not at all reflect what you think you're looking at, right? Because that little callout could be in some markup that's interleaved with other parts of it. So you may be trying to select this and you paste and then you ended up with the callout as part of what was pasted. So yeah, copying and pasting from PDF is, it's a crapshoot. You know, maybe you get something that you expected and you may not. And this was an actual bug report that I had to respond to in Microsoft, where we had some localization testers specifically dealing with a China standard called GB 18030. They were selecting characters out of the Unicode code charts. And if you look at the preamble of each of the code charts, they say, don't copy and paste from the code charts because there's no guarantee. And again, people will often say, oh, wait a minute, these glyphs don't match a particular style. So we started off with the Simson font, but in this context, it was showing up in a different way. As mentioned earlier, the only guarantees of font fallback is that it's trying to make the text legible. It's not necessarily making it pretty. right? So it's not necessarily going to match the style. So you need to set your expectations accordingly. And as Ned mentioned, depending on the software, it may be using different things to try to do a better job at how it selects fallback fonts. But at the bare minimum, it's just trying to make it legible. Sometimes you will see cases like this, and these are both cases where, well, there wasn't any fallback that happened. All you're seeing are the not def glyphs from a font. As Ned mentioned, that it's up to the font designer to decide what they're going to make the glyph 0 look like. And so with the fonts that you're going to be dealing with, it's a good thing to get familiar with what does the not def glyph actually look like, so that when you see some things like this, you recognize, oh, yeah, that's what's happening. There was no fallback.
And in one of these cases, the first one, it wasn't actually a failure of the software. It was simply a matter that there was no font available to render those glyphs. And so, again, it's a question of, well, what can we do about that?
Sometimes you'll see text that's truncated, and particularly when text is sitting inside some text control, especially for single lines of text, those text controls they're going to have some frame. Whether they actually show a border or not, the control has a particular size. And they may not be anticipating the particular characters that show and what the height requirements of those characters are. Different writing systems have different vertical requirements. Here I'm talking about horizontal text layout, but some just require more space above and below a baseline, right? So what was done in that particular, in the lower example, you see there's a little bit of adjustment. And so that could have been a font change. It could have been adjusting those ascent and descent metrics. It could have been an adjustment made in the software. But when you see these things, you need to be able to recognize or understand what font was actually being used to display this, and what was the text control, and figure out which of them maybe needs some adjustment. You may end up seeing things like this, where it's just garbage text. And now earlier we saw those square boxes, which were cases of the not def glyph out of a font. These are cases where something is displaying and it's just garbage. And these are cases where it's not a failure in the font or in text layout, it's something coming earlier upstream. Something was failing to incorrectly convert the text from one encoded representation into another encoded representation. So up at the top, I saw this not too long ago from a music streaming service where, yeah, playing Frédéric Chopin, his Études, and you expect to see these letter E with a cute accent on it, and it's showing up as this gibberish sequence of characters. What's actually happening here is that the text was encoded in Unicode, but some part of the software didn't know that it was encoded in Unicode, and it was assuming that it was actually encoded in a different encoding. And so then it was attempting to convert it into Unicode. What was already in Unicode, it was converting again, and it ends up with that kind of garbage. That's actually not uncommon these days. If you see these kinds of sequences where you expect one character, you think, oh yeah, it should be this, but you're seeing these combinations, it's a failure for correct processing of UTF-8 encoded text.
So we had this in Myanmar, right? We had Zaji and Unicode. There was a coding, two different encoding. But for this, what other encodings do we have besides Unicode for, say, Latin scripts?
So, question: we saw issues in Myanmar with text using what's referred to as Zaji encoding. What are other encodings? So before Unicode was prevalent, there were a lot of different, what we refer now to as legacy encodings. So for instance, on the, going back to the IBM PCs, in the US, typically you were using something called code page 437. On Windows, that example up there is actually converting the UTF-8 text, or treating it as though it is encoded in Windows code page 1252, which was an 8-bit encoding used for Western European languages, right? But you could that's a very common case of assuming it's code page 1252 when it's not actually. But it could be any number of other legacy encodings, encodings for shift-JIS for Japanese, a variety of different encodings. What we see in the next example is a case of older software that is simply not Unicode capable at all. And so the data that it's trying to display is some Unicode character sequence, but it has to present everything in terms of some legacy code page, because that's how the software was written. Here it's showing question marks, and that's something that you'll often see on older Windows software, because there were APIs that would, in these cases, say, well, you're trying to convert and that character isn't supported in the target, so I'm just going to replace it with the question mark character. The next line is another thing that you might see. The thing that looks like a question mark, there is actually a dedicated character in Unicode called the replacement character. And its intention is, if you're trying to convert something and you don't know what it is, you can use the replacement character. So Morgan, in one of our assignments in the Blogger corpus, I have found occurrences of the replacement character. Why is it there? Who knows? This last example, yeah, it's a file name. I don't think that's what the person creating the file actually called their character, but something has no, it's just complete garbage. That was probably from a legacy, like GB2312 encoding, is my guess. So, key point here, these are not text display issues. These are all failings of text encoding conversion happening before any text display happens.
One of the examples that Peter gave was talking about trying to convert a UTF sequence into a code page encoding of some sort. As he noted, this replacement character hopefully is used by the software to indicate that something went wrong, as opposed to proceeding anyway and doing what it can do. There are some really weird things that can happen when you're dealing with software. In this particular case, we have an example where it's trying to replace some text with an ellipsis to show that there's text being left out, but it doesn't realize that the text encoding here might vary in width for each character. And so, you know, UTF-8 and UTF-16, they actually represent characters as one or more individual code units. And so in this case, the software is simply doing the wrong thing and trying to replace part of one of these characters with something, and we see the replacement character again.
Yeah, these were actually, again, actual bug reports, again, from GB1830 testing, and old text controls that were not properly handling the Unicode character sequences, and thinking when it needed to shorten it to insert an ellipsis, just assuming that, oh, every 16 bits is another character, not realizing that, well, some characters have two 16-bit chunks in their representation. So it's just dividing those in half, and half of that is just gibberish.
We'll just skip past this slide. We included it just as another example of some sort of strange failure that we've seen. P-way characters are not meant to be sent from one system to another, but here we have it, and we can't complain about it. And it continues. The main point we're trying to make with some of these examples is that, especially if you're dealing with localization or testing or anything, you may encounter some unexpected text display. And in those cases, we encourage you to start a conversation with your friendly resident text display engineer, or a mentor that you may have, or an expert in the language that you're dealing with, and be prepared to either provide or obtain more information about what was happening when we saw this strange behavior. Because in many cases, there's a lot going on in the software to try to produce the text display. You may remember early on, we had a whole slide of things we weren't going to talk about today. And it might be that there's some interaction in all these different steps that is causing this unexpected behavior. And so maybe some of these slides with examples may help you sort of like key in on what area might be most at fault, but there might be something else going on. And as to how to fix that problem, you need to take all of that information together and figure out, what might be going on. So we can't diagnose every problem that you might see, but it can be an entertaining process sometimes to figure out what went wrong in any case. So hopefully with the information that we've provided you as sort of a background, you won't need to pick it up in anger at some point. Hopefully you have some better understanding and you can either dive deeper into these topics or just use this as a starting point for your own problem solving. So with that, thank you very much for attending. Again, we'll be around if you have any other questions. Please come up and chat with us. We're happy to dive deeper or provide you more references. And thank you once again.
We do have a few minutes, so are there any questions in following up people would like to ask?
Thanks. I have a question. The user's editing a document. Are you rerunning this processing every time they type a character? How do you make that efficient so it doesn't slow down?
So the question was, as somebody's editing a document, do you have to run through all of these processing steps again? In theory, yes, although you can optimize that in certain ways. For instance, if you know that none of the changes on a single line affect the lines before and after, then you may only need to redraw that one line, right? Or you may be able to determine that any effects, so there can be a ripple-on effects, right? For instance, if I insert a word, obviously I'm making that line longer, that may cause the text reflow, then I have to relay out all of the subsequent lines. But even shorter things can have ripple-on effects within a single line. But there may be ways to determine that the range of impact could be constrained, and then you only want to relay out that portion of that text. Any other thoughts?
Yeah, I mean, so it took us quite a while to get through all of the sort of like examples and explanations of what happens with text layout, but it's important to note that showing text is one of the most common things that computers do. And the software and the font data itself are generally arranged in such a way to make this relatively efficient. So again, even if we have to lay out an entire line or multiple lines, you can pretty much always assume that something is being done in the software at some point to try to minimize the impact of that, because people edit documents all day long. We can't be waiting for that to change after every keystroke and pause while it updates. So hopefully the software is doing the right thing in trying to provide good results quickly.
There was a time when software would differentiate, is this, for instance, is this Latin text? I'm going to assume if it's English text, for instance, that we don't need to do all of that complex processing. If it's Arabic text, well, I can't avoid it. But for performance reasons, it would limit certain, like English text, to just basic layout, which meant you didn't get any typographic nicety, right? Today, hopefully, these performance issues are not hindering good typographic quality.
So let's say that I want to render a string text, right? And I provide the font engine with all the fallbacks that I want. When does the rendering system decide, makes up its mind on the what font it's going to use for each run? Is it after the language, the script is determined, or like when exactly is that?
That may differ in different implementations.
Oh, the question.
I'm sorry, yeah.
The question is, if you have text and you have a list of fallback fonts that you want to consult, at what point in the process do you look at those fallback fonts to resolve any missing characters? And I'll just answer quickly because I think we're out of time. It's really dependent on the software. Again, this is one of those things where, depending on the goals of the application, it might do things differently. Or if you are simply a system text control and you just need to do something fast, whatever that is, it might make different decisions. But ultimately, you are constrained by what the fonts are capable of. And so you might not need to necessarily perform script analysis or bidi in order to realize that you are going to need a different font. Or you might want to perform that script analysis right away so that you can pick up a better font, right? So this is, again, there's no single behavior for font fallback. And so hopefully if you have specific requirements for your fallback fonts, you don't use fallback and you just pick the font from the menu and you say, this is the font I need to use. But again, it's an area of interest for me because, again, like, you want to be able to read it, but hopefully it looks nice too. So hopefully software is going to take that into account when it decides how to perform these operations.
One final point about fallback. If you're going to be doing localization, don't depend on fallback to make your text look good, right? So the font selection should be one of the attributes that gets localized. With that, we're at time. Thank you all very much. I hope you find this useful. Yeah.
Oh, yeah.
Perhaps if people have questions, they could come here.
Okay, so it looks, okay. So just a reminder, if you weren't able to hear Toral's intro this morning, unfortunately, the presenter of the afternoon session, Making Fonts for Unicode, Glenda Bellarosa, is ill and won't be attending. So that session at 11:30 will not be happening here. So there's a break until 11:30. If you want to stay in this room after that, there will be no presentation here.
Your question, if you want.
If we wanted to, sure. We'll work that out. So you, again, break now until 11:30, and then putting ICU to work will be in EQI next door. No presentation here, although we'll be back to the regular schedule after lunch. So, right, in this room. Thank you very much.
Thank you.